Namaste, dear students. Today we are going to discuss about atomic structure, chemical bond, in which we are going to talk about electronic configuration, ion, as well as the valency. Is in our previous class we discussed about the atom, subatomic particles, as well as the proton, as well as neutron, and the electron, and their locations. Where do we find these subatomic particles? Is what are the smallest particles of the atom? Would you mind to imagine for some time? Yeah, yes, you are thinking about proton, electron, as well as neutrons. They are the subatomic particles which are found inside the atom. So, as we earlier discussed about the smallest particle of an atom which can take part in chemical reaction. So, the atoms have got different the smaller particles or the subatomic particles. So, these particles are they do consist the different types of charges, like proton consists positive charge, as well as electron consist negative charge, and the neutron does not consist any types of charges. In the same class, we had discussed about the subatomic particles, like I am just showing the atomic structure of sodium, in which electrons are being revolved around the nucleus, as well as the proton and the neutrons lie at the center of the atom. So, the path followed by the electrons which are being revolved around the nucleus, they are called the orbits, as well as they are also known as the energy levels. Likewise, in the second atomic structure also, I am just showing the atomic structure of helium, in which 2 electrons are being revolved around the nucleus, and nucleus have got 2 protons as well as 2 neutrons. So, from the previous class, just we are reviewing the previous class, that is protons as well as neutrons, they lie inside the nucleus, and electrons are just revolving around the nucleus. So, they are just outside from the nucleus. You can just see these structures, like the structure of beryllium here, in which you are looking 4 protons at the nucleus as well as 5 neutrons at the nucleus, and 4 electrons are found at the orbits. In the first orbit, there are 2 electrons. Is in our earlier class, we have discussed that in case shell, 2 electrons can be accommodated. So, you can see here 2 electrons are found at the first shell, as well as remaining 2 electrons, they are kept in the second shell. Even second shell can accommodate 8 electrons, but in beryllium only there are 4 electrons. So, out of 4 electrons, 2 electrons are being put at the or kept inside the first shell, that is K shell, as well as in the second shell we have only 2 electrons. So, these are kept at the second shell, that is L shell. So, just in the second figure you are looking there, the how does the electron revolve around? Do they revolve in the same path, or they do have got the different path? The electrons of different energy levels or different orbits can revolve by making the different paths. Just you can see there, the electron of the first shell can revolve through the one path, as well as the electrons of the second shell can revolve through the different path. So, in our previous class we talked about these things, but today we are going to talk about how do these electrons can be configured into different orbits or different shells. As we have discussed the formula, that is 2n square, where n refers for the number of energy levels or number of orbits. You can see in the table that in the context of hydrogen, there is only one electron. So, it has been kept, the electron of the hydrogen has been kept in the first shell, because we do have got only one electron. But in the second, that is in the helium, there are 2 electrons. So 2 electrons have been put in the K shell. So no more electrons are left. So we cannot put the rest of the electrons here because we do not have got the more electrons. But in the context of lithium, you can see here altogether there are 3 electrons. These 3 electrons are being configured in 2 cells, because in the first K shell can accommodate only 2 electrons. Yeah, so the next third electron has been kept in the L shell, because K shell cannot accommodate more than 2 electrons. By the same way, we can configure the electrons of beryllium also. So altogether beryllium has 4 electrons. So 4 electrons have been configured into 2 cells, that is K can accommodate only 2 electrons, as well as L cell can accommodate 8 electrons, but we do have got only 2 electrons. So these 2 electrons have been put in the L cell here. Likewise, in boron consists 5 electrons. So 2 electrons have kept in the first cell, that is K shell, as well as 3 electrons have been kept at the second cell, that is L cell. By the same way, we can configure the electrons of other elements also. So just you can see the electronic configuration of sodium. Here sodium has got altogether 11 electrons. So these 11 electrons have been configured into 3 cells. They are K shell. K shell can accommodate only 2 electrons, as well as L shell can accommodate 8 electrons. L shell cannot accommodate more than 8 electrons. So the rest of 1 electron, that is the 11th electron, has been kept at the M shell. By the same way, magnesium has 12 electrons. So these 12 electrons have been configured like this. So in the first cell, that is 2 electrons, in the second 8 electrons, as well as in the third cell, that is M shell, it accommodates 2 electrons. By the same way, we can configure the electrons of aluminum, silicon, phosphorus, sulfur, as well as chlorine. So up to chlorine, you can find the similar trend that has followed the electronic configuration. That is, in the first cell, it has accommodated 2 electrons. In the second cell, it accommodates only 8 electrons, as well as in the M shell, it accommodates 7 electrons, because we do have got, or the chlorine atom does have got only 17 electrons. So up to here you can get 17 electrons. But in the argon, when you configure the electrons of argon, it has altogether 18 electrons. These 18 electrons have been configured by this way, that is, in the first cell, that is 2 electrons, in the second cell 8 electrons, in the third cell, that is M shell, 8 electrons. At the valence shell, that is in the outermost orbit, it has got 8 electrons. According to the discussion that we have made in our earlier class, that if the atom accommodates 8 electrons in its valence shell or the outermost shell, then this state of an atom is also known as the octet state. So in this configuration, this atom of argon has accommodated octet state, because it does have got 8 electrons in the valence shell. So argon is in the octet state. Similarly, we can configure the electrons of potassium also, that is altogether it has got 19 electrons. So these 19 electrons have been configured into 4 different cells, that is K shell can accommodate only 2 electrons, as well as L shell can accommodate 8 electrons. So it has been kept 8 here. By the same way, M shell can accommodate 8 electrons, but M shell can accommodate 18 electrons, but we to make its electronic configuration, that is electronic state a bit more, that is in the valence shell it can accommodate only 1 electron. So the last electron has been put at the N shell. As well as in the calcium also, it has got the similar electronic configuration. At the valence shell, there are altogether 2 electrons. So by discussing these type of electronic configuration, we do have got some conclusions that the number of electrons that has been present at the valence shell, that represents its, that is, combining tendency or the reacting tendency with other atoms. So generally, the combining capacity of an atom with other atoms while making the compounds, this tendency of an atom is also known as the valency. So you can see here, that is, I have given two atomic models here. That is, the number of electrons that can take part in chemical reaction by sharing or by transferring the electrons is called its valency, or the valency of the respective atom. How many electrons can the atom does share or does transfer from one atom to another atom? It matters its reactivity, as well as it matters for its that combining tendency of the atom. Likewise, in the first, you can see altogether 1, 2, 3, 4, 5, 6, 7. 7 electrons are found at the valence shell. That means, to be octet for this atom, it requires one more electron. So, if it acquires or if it gains the electron from other atom, one electron, then this atom attains the octet state. That means, it becomes a bit more stable, or it acquires the octet state. So, it needs one more electron. So, it has got the valency 1, because to make the bond with other atoms, it requires one more electron. So, in this sense, this atom is considered, or the valency of this atom is considered 1, because it has just gained the 1 electron to become octet. By the same way, if you see this structure, you just count the number of electrons present at the valence shell. That is, it consists only 1 electron in the valence shell. To become the stable, this atom either gains 7 more electrons or loses 1 electron. Which task is easier? To gain 7 electron is easier, or to lose 1 electron is easier? Just make imagination. Yes, according to your imagination, this atom feels more convenient to lose 1 electron rather than gaining 7 electrons. So, it does have got the tendency to lose 1 electron, so that if this 1 electron is being lost, obviously it acquires, or the inner shell has got 8 electrons. So, it has got, or it will acquire the octet state. So, it becomes more stable. So, this type of tendencies of the atoms, either by gaining the electron or by losing the electron, or by just sharing the electrons or by transferring the electrons, they do have got the that capacity or tendency to make the reactions with other atoms. So, this tendency of an atom is known as valency. The valency of the atom matters or determines by the number of electrons present at the valence shell. Like, if the electrons of valence shell, or that is outermost shell, only involved in chemical reaction to form a compound, such atoms have got only one valences, because different atoms may have got different valences. Some of the atoms may have got single valency, as well as some of the atoms may have got valency one more than one, that is 1, 2 or 3 and so on. So, if the electrons of valence shells are only involved while doing the reactions with other atoms, these type of atoms do have got the only single valency, like sodium. Sodium has valency 1, because in the valence shell of sodium, it has got only 1 electron. So, this electron will only involves for the combination of with other atoms. So, it has got only 1 valency. But in the context of iron, if you see the iron does have got 2 valencies. Sometimes iron shows the valency 2, sometimes iron shows the valency 3, because while combining iron with other atoms, the electron of 2 orbits may involve. So, if the atoms have, or if the electrons of different orbits are involved while doing the reactions, then this type of atoms to have got the valency, or that 2 valencies, like 2 as well as 3 of iron. So, in the context of this structure, as I have just talked about this, it has got only 1 electron in the valence shell. It has got only 1 electron in the valence shell. So, this atom wants to lose this electron, so that it wants to acquire the octet state. So, it loses 1 electron, or the electron of only valence shell is involved while making the bond with other atoms. So, it has got only 1 valency. By the same way, in the second structure also you can see here, it has one electron in the valence shell. So, either this atom can gain the electron or can share the electron, or it can lose the electron of the valence shell. So, it also has got the single valency, that is, it also have got the valency 1, as well as this atom also have got the valency 1. But in some cases, like in the context of iron, you can see here structure of iron. So, it has got 2 electrons in the valence shell. So, if these 2 electrons are being lost by the atom, then it shows, or it does show, the valency 2. But sometimes the electron of the inner shell also involves, or the electron of the second last orbit also just lost. So, in this context it shows the valency 2, that means it shows the valency 3. Here, if these 2 electrons are lost from the outermost orbit, then it does have got the valency 2. But if the electron of the innermost orbit, that is inner orbit from the outermost, then it can show the valency 3 also. So, you can see the table here, the iron has got valencies 2, that means sometimes it shows the valency 2, as well as sometimes it shows the valency 3. As I have just talked about this, if these 2 electrons are being lost, then this iron shows the valency 2. But if the electron of this inner orbit also loses, then it shows the valency 3, because altogether from this atom of iron, 3 electrons are being lost. So, in this sense, the valency of iron is considered 2 and 3. Likewise, in the context of silver, if it loses 1 electron from the outermost orbit, then it will have got the valency 1. But when it loses the electron from the inner orbit, from the inner orbit also, then it will show the valency 2 also. So, it does have got the valency 1 and 2. Likewise, in the context of gold also, sometimes it shows the valency 1, as well as sometimes it shows the valency 3 also. And in the mercury, it shows the valency 1, as well as it shows the valency 2 also. So, by this discussion, I think you are just knowing the gist that, or knowing the fact that when the atom loses the electron from the, loses or gains the electron from the valence shell only, then it does have got the single valency. But if the electrons of the inner orbit also involves to make the bonds by losing the electron, in this context it does have got the 2 or multiple valence system. So, this is the gist, as well this is the conclusion of the discussion that we have just made. Similarly, as we have discussed in our earlier just that immediate slide, that is the electrons have been lost, but here we are talking more some examples, that is we are taking the atom carbon. Carbon has 4 electrons in the valence shell, like this red ball indicates the electron of carbon. So, altogether red balls are 1, 2, 3 and 4. But one carbon atom is sharing the electron of 4 electrons of the 4 atoms of hydrogen. That is 1 electron from this atom of hydrogen, 1 electron from this atom of hydrogen, as well as 1 electron from the atom of this hydrogen. Similarly, 1 electron from this atom of hydrogen. So, altogether if you see this structure, then you will find that hydrogen is gaining the duplet state, because hydrogen cannot gain more than 2 electrons, or hydrogen cannot accommodate more than 2 electrons in its valence shell. It has, or it does have got 1 electron in its own, but it has sharing the electron with the carbon also. So, if you see this structure, then you will find 2 electrons of the at the orbit of hydrogen. But if you see this larger orbit of carbon, then you will see altogether 1, 2, 3, 4, 5, 6, 7 and 8. So, carbon is gaining, carbon is attaining the octet state. So, altogether if you see this structure, in fact this is the molecule of methane. So, in this methane 1 atom of carbon is being involved, but altogether 4 atoms of hydrogen are being involved for making the molecule of methane. So, here this is the combining capacity, that means while combining hydrogen with carbon, carbon has gained 4 electrons from 4 atoms of hydrogen, as well as hydrogen is gaining 1 electron from the valence orbit or valence shell of the carbon. So it has made, or the molecular structure of this methane is possible. So this is the tendency of the hydrogen atom as well as the carbon atom. So this tendency as well as combining capacity of carbon as well as hydrogen, that is called the valency. Similarly, in the context of ammonia molecule, altogether if you configure the electrons of nitrogen, then it has got the 5 electrons in the valence shell. So out of these 5 electrons of the nitrogen in the valence shell, 3 electrons are being shared with hydrogen, one with hydrogen, another with hydrogen, as well as this circular ball, that is spherical balls, represent the electrons present in the valence shell of the nitrogen, as well as this cross line or cross electrons indicate the electron of the hydrogen. So altogether in the valence shell of hydrogen, you will see there are 2 electrons in this hydrogen atom also, in this hydrogen atom also. But when you count the total number of electrons along with the electrons shared from the hydrogen, then you will find altogether 8 electrons in the valence shell of this nitrogen. So nitrogen has acquired the octet state as well as hydrogen has acquired the duplet state in each atom of the hydrogen in the ammonia molecule. So this is the tendency of the atoms of the hydrogen as the nitrogen. So this tendency is known as valency. So this structure is possible due to the combining tendency of the atoms of nitrogen as well as the hydrogen. Similarly, if you see the molecule of water, so in the valence shell of oxygen, there is 1 atom of oxygen as well as 2 atoms of hydrogen. So in the valence shell of oxygen, altogether there are 1, 2, 3, 4, 5 and 6 electrons. So these 6 electrons are found at the valence shell, and one hydrogen atom has shared 1 electron as well as another hydrogen has shared 1 electron. So altogether if you see this structure of hydrogen, inside of it you will find altogether 2 electrons. That means hydrogen has acquired the duplet state, as well as this hydrogen also has acquired the duplet state, and this oxygen is acquiring the octet state. So this molecule is being formed by sharing the electrons. So this either by sharing the electrons or by transferring the electrons or by mutual sharing of multiple atoms within the valence shell, this tendency, or by making some compounds or the molecules by sharing as well as transferring electron, this tendency is known as the valency, or this is also known as combining capacity of atoms. What happens when if atoms lose the electron? Because atoms are electronically neutral, because total number of proton as well as total number of electrons found in the atom are exactly alike, that is same. If there are 10 electrons in an atom, there must be 10 protons. Electron consists negative charge as well as proton consists positive charge. So if there are same number of positive as well as the negative charges, obviously the atom is electronically neutral in the uncombined state or unreacted state. You can see the structure here. You can just what is happening in the figure. I'm just taking 2 atoms, that is, this is the atom of sodium metal as well as this is the atom of chlorine. You can see in this structure, sodium metal has 1 electron in the valence shell, and the electron of the valence shell is being lost here. So it is acquiring positive charge, that means it is acquiring 1 positive charge here. How does this sodium metal acquires the positive charge? We can calculate mathematically, like there are 11 protons. Protons consist positive charge as well as 11 electrons. So electrons consist negative charge. If you sum up these 2 electrons, because this proton consists positive charge as well as this electron consists negative charge, then electrically it is neutral, because there won't be any surplus charges or residual charge won't be seen there, because 11 plus as well as 11 minus means 0. But if sodium metal is losing one electron, then obviously it will be altogether 10 electrons there. Then you will get one positive charge. That means there will be one positive. So one positive means we can say Na is losing one electron, then you will get Na plus. So this plus is represented by this structure like this here. This plus is this one, and structurally or structure of atom of the sodium can be represented by this way. Similarly, in the structure of this chlorine also, altogether there are 7 electrons in the valence shell. Just you can count 2, 2, 2, 6, and this is 1, 7. Altogether there are 7 electrons. But when this chlorine gains 1 electron, then it will acquire the octet state. So in this octet state, we can calculate by this way. Altogether there are 17 electrons as well as 17 protons in the atom of chlorine. Then it is electrically neutral because negative charge 17 as well as positive charge altogether 17, then it will be 0. But when this atom of chlorine gains 1 electron, then it will be altogether 18 electrons. Yes? Yeah. Okay. Then the number of proton cannot be changed. So if you sum up them, then you will get 1 electron. That means the chlorine atom is gaining 1 more electron, so that it acquires negative sign there. So we used to write it as Cl minus. By the same way, it can be represented in the structure like this. Then just you can see the structure. This sodium from this sodium metal, 1 electron is being lost, as well as towards the chlorine, this chlorine atom is gaining that electron which is being lost by the sodium metal. So the electrically charged particles or charged atoms, they are known as the ions. Is sodium has formed the Na plus or positively charged, as well as Cl has formed the or acquires or attains the negative charge. So electrically they do have got the positive as well as the negative charges. So by gaining the electron or by losing the electrons, the atom are gaining the charges. So this state of atom is also known as the ions. Electrically, as I have told to you that the atoms are electrically neutral, but when they gain the electron as well as when they loses the electron, then they will have got the charges. So this charge state of atom is known as the ion. Some of the ions are positively charged because in the context of sodium, sodium has lost 1 electron, then it gains the positive charge because there will be a more number of the protons rather than the number of electrons. So it is gaining the positive charge here. So we used to write it is Na plus because sodium metal has lost 1 electron and it has gained the 1 positive charge, or it has acquired the positive charge. So this charge is known as, or this ion is known as the positively charged ion. And in other words, this can also be termed as cation, because in electrolysis these positively charged chemical species move towards the cathode of the cathode. Okay, so this can be termed as, or this can be named as, or can be termed as the cation, because it moves towards the cathode of the cathode during electrolysis. Similarly, we do have got some positively charged ions. You can see the table that some of the positively charged ions have been kept here, like lithium Li plus, because it shows, or the number of positive charge indicates the total number of electrons that has been lost. So if you are looking Li plus, then you need to know that lithium has lost 1 electron, as well as if sodium is acquiring 1 positively charged, then we need to conclude that sodium has lost 1 electron, so that it has become positively charged. Likewise, potassium K plus as well as ammonium NH4 plus, cuprous Cu plus, as well as silver Ag plus, mercurous Hg plus, aurous Au plus. Why do we used to write aurous, but aurous as well as aurous for gold, as well as cuprous Cu, OUS at the as a suffix indicates there should have got the lower valency. In such cases, they do have got, or such atoms do have got multiple valencies. That means sometimes they show the valency 1, sometimes they may show the valency another 1. Like cuprous indicates it has got 2 valencies, that is valency 1 as well as valency 2. Os indicates the lower valency system of the atom, like Cu plus. When we say the cupric, just you can see here, cupric indicates as a suffix, if you find IC, it indicates the higher valency system, but OUS indicates the lower valency system of the respective atom. In the context of mercurous also, we are writing OUS here, so it has got valency 1, but you are looking mercuric here, so it is losing, or it has lost 2 electrons, so it has got the 2 valency system, that means 1 and 2. Os indicates lower valency state, as well as ec state indicates the higher valency state. Similarly, you can find the ions having valency 1, ions having valency 2, ions having valency 3, and so like boron has the valency B plus plus plus, that means it has lost 3 electrons from its valence shell, as well as aluminum has lost 3 electrons, so that it has acquired the 3 positive charge, that means Al plus plus plus. And ferric, as you have talked about ferrous, as I have told you that Os indicates the lower valency system, as well as Ec indicates the higher valency system. So this shows the valency 2 because we are looking Os here, as well as this shows the valency 3 because we are looking Ic as a suffix here. By the same way, in the context of aurous also, you are looking here Os in the first state, Ec in the third state. That means it shows the valency or higher valency, that means valency 3, but it shows the valency only 1. Is the positively charged ions are found by losing the electrons, and if these lost electrons are being gained by other atoms, generally non-metals gain the electron lost by the metals or the electropositive species. So these lost electrons of the atom will help to become the non-metals negatively charged. So these negatively charged ions, when they gain the electron, these ions are called the anions, because during the electrolysis process, these electrons move towards the anode, that is positive terminal of the battery. So they are known as the anions. So you can see here chlorine has got 7 electrons, then to gain the octet state or to become stable, or while combining with other atoms, they will acquire 1 electron, then it becomes negatively charged, because we have just discussed that when the atoms gain the electron, they become negatively charged. So chlorine also gaining 1 electron, so it is acquiring 1 negative charge, so it is known as the anion. Similarly, we do have got some list of the ions. They have got the negatively charged, and these negatively charged are due to the gaining of the electron for other chemical species while combining or while doing the reactions. Like fluoride, it indicates it has gained 1 electron, so that it acquires the negative charge, as well as chloride, it has acquired 1 electron, so that it has gaining 1 electron, like Cl minus, and bromide, iodide, and so on. But we do have got some collection or groups of the atoms. They represent the okay, while doing the chemical reactions, they do have got the behavior like that of atom, but they are the collection of the atoms. So they do have got the charges also. So this collection of or group of the atoms that represent or that behaves like that of the atom while doing the chemical reactions, this group is also known as radicals. So you can see here, that is NO3 minus, OH minus, HCO3 minus, and ClO3 minus. So they do have got the collection of atoms and they have got the charges. So this state or these groups are called the radicals. So anyway, they do have got the negative charge, so they are called the anionic radicals also. Likewise, the list of the ions, they do have got two valences, like oxides. When um, the atom of the oxygen, uh, it acquires or it gains 2 electrons while combining with other atoms, so it shows the valency 2. Likewise, sulfide, sulfate, carbonate, they do have got the valency 2. As well as in the third list that we will find, there are some radicals as well as some ions which do have got the valency 3, like nitride, and minus, minus, and minus. It shows that nitrogen is gaining 3 electrons to become octet, or to gain octet state. So it has acquired the 3 negative charges. So n minus minus minus, that is known as, chemically it is also called as nitride. And phosphate, PO4 minus minus minus. So these are all about the types of the ions that have got the different charges. To make our today's discussion a bit more effective, as well as to evaluate for your learning achievements of today's class, we are going to discuss some questions. Like, you can see a question, according to the atomic structure given aside, that means this is the atomic structure given to you, then you can study this structure. Then what could be the valence of the given atom? You should have got the tendency, that skill to identify the valency of the given atom. That means either it 1, 2, 3, or 4. Just you can see there is only one electron in the valence shell, so it can lose this electron, and it does have got the valency 1. So valency is 1. I think you had also guessed the same answer. So I hope you have got the correct answer. Now, what is cation? We have discussed that the atoms which loses the electrons, then they do have got the positively charged that radicals or the ions, then they are called the cations. As well as what does the given atom form? Please study the atomic structure given over the screen, then write the answer of this question yourself there, then I will give the answer of these questions also. So altogether there are 7 electrons in the valence shell. That means this atom obviously gains 1 electron to gain the octet state. So if this atom gains 1 electron, obviously it will have got the surplus amount of the electrons. So that means it acquires the negative charge. So if the atom is negatively charged, then what does it call? Yes, you are thinking that it is called the anion. So it forms the anion. By the same way, we have got some questions that if an atom having 8 electrons is treated with the atom having 11 electrons, you need to, what is the atom that consists of 8 electrons? Yes, oxygen. As well as it is being treated with the atom which have got the total number of electrons 11. That means 11 electrons bearing atom is the sodium. So here is the reaction between sodium as well as oxygen is being taken place. So which compound is formed when sodium reacts with oxygen? Obviously it forms sodium oxide, that is Na2O is the molecular formula of sodium oxide. Fill the balances of the ions given table. That means cuprous, what is the valency of it? As well as you have to fill this table. What is the valency of cuprous ion, as well as what is the mercuric ion, what is the valency of phosphate, ferric, chlorate, and auric. What could be the valencies of these ions or radicals? You have to please fill in your copy and check whether it is correct or not. Cuprous has got valency 1, mercuric has got valency 2, phosphate has valency 3, ferric has valency 3, chlorate has valency 1, as well as auric has valency 3, because these things have been just discussed in our earlier slide. So these are the discussions that have just been made for the for our that learning achievements. Now I'm giving one project work for you. That is, you should prepare an atomic model of magnesium and chlorine by using tennis ball, metal string, tape, and stand. Take these materials and try to make the atomic model of magnesium, chlorine, then demonstrate the process of formation of positively charged ion and negatively charged ion in the above ions. When magnesium reacts with chlorine, then how does the electron of the magnesium shift towards the chlorine? Please try to make the general explanation over your chart. So that's the end. I think today you enjoyed a lot in my class, and I hope you learned many things in today's class about electronic configuration, ions as well as balances. And we'll meet in the next class. Thank you very much.